Good afternoon. My name is KHare. This is case number 3 for BBUS 502 Business Statistics. The sophomore Jinx, myth or reality? And like I said, we'll be talking about the sophomore Jinx, so it seems only appropriate to define what we're talking about first. Claremont University defined it as a phenomenon that occurs when the second effort of a group or individual fails to match the success of the first effort. I've got a couple of examples outside of the business world and outside of sports, but they pretty much occur across the board. So in music, I have Hootie and the Blowfish with their debut and sophomore album and the obvious difference in sales. And in sports, I have Matt Ryan with a 3,500-yard rookie season and just barely cracking 2,000 yards in his 2009 season. So we're talking about baseball today, and that's a sport that I don't really follow very closely, so I figured I'd define a few of the terms that I had to look up. That would be ERA, batting average, and slugging average. And ERA refers to the number of runs a pitcher yields to the opposing team, and batting average is the fraction of successful at-bats, while slugging average is the ratio of total bases that the batter achieves to their total number of at-bats. And the next column over is how to calculate these measures. Now to set up our problem, I have our hypothesis. If a group or individual has an exceptional first effort, then the second effort will fail to achieve the level of success of the first. And stated mathematically, we have our null hypothesis, which is mu1 minus mu2 is equal to 0, which is there is no sophomore jinx. My hypothesis is incorrect, and there is no statistically significant difference between rookie and sophomore year. And then our alternative hypothesis is, when it's proven, the sophomore jinx exists, and there's a statistically significant difference across the measured years. And finally, our decision rule: if T observed falls outside of the range of T critical, then we reject the null hypothesis. So the data table that we were given, was Rookie of the Year award winners for the American League and the National League, both batters and pitchers. What I did was consolidated them into one table of pitchers and one table of hitters and calculated the means and standard deviations to get a first look at whether there's appeared to be a drop in performance across the 2 years. In addition, after I calculated the means and standard deviations, the format of data analysis I chose was a paired t-test to figure out if my hypothesis was correct or not. I chose an alpha level equal to 0.05, which gives us a 95% confidence level, and I did eliminate a few of the statistical measures to check for sophomore jinx because I thought they were not as much related to individual performance. So for pitchers, I chose to run tests on ERA, and batters, I ran the test on both batting and slugging average. So here's the data. As you can see, there appears to be a decrease in performance across measured years, but without our paired t-test, we can't decide whether that's significant or not. In addition, here are the batters, and like the pitchers, there appears to be that decrease in performance across year 1 to year 2. An added note with the batters, I had to exclude 2012 Rookie of the Year Mike Trout from the data set, as we were given no data for his sophomore season. And as the tables prior showed, and the t-tests now confirm, the sophomore jinx does exist. In all cases, T observed falls outside of the range of T critical, and therefore we must reject the null hypothesis and see statistically significant evidence of the sophomore jinx in all 3 variables that I tested. Now, some limitations and assumption of the data and analysis. This is a large data set, but it's far from perfect. First thing we have to assume is the data is relatively normally distributed, and we need to assume that there is a third variable effect, and the limitations of the data, it's missing a large number of entries. It's not really a very random sample, and the data is incomplete. A required assumption of the paired t-test is the data be relatively normally distributed. This is a test that has a higher level of tolerance for skewed data, hence the relatively normally distributed part. Second, the third variable effect. Baseball is a team sport, so the numbers that you're seeing could be influenced by the way the rest of the team is playing or the team that you're playing against. So I chose to limit my analysis to metrics only influenced by the player. So I omitted testing on wins, losses, games played, and innings pitched. The limitations of the data. The set is missing 91 entries from award-winning pitchers and 35 entries from award-winning batters. The inclusion of these entries would greatly increase the validity of the testing simply by increasing the sample size. So this is not a random selection, it's only Rookie of the Year award winners. There are approximately 750 active players in the MLB in any given year. If you just took the top 10% of these players, you would add an additional 75 entries minus the 4 Rookie of the Year award winners, so you'd have another 71 points. And given the definition of the sophomore slump, the top 10% of the best baseball players would probably follow the same pattern. And finally, as I mentioned earlier, we had to exclude one data point of Mike Trout from 2012 because we had no data on his sophomore season. And in business, the sophomore slump appears all the time. We have startup companies that have wildly successful initial offerings and their secondary offering just doesn't cut it. Quite a bit of research has been done. Two researchers from UC Berkeley studied CEOs that have won awards, and over the course of 1975 to 2002, they found that on the outside, these CEOs looked awesome. They were making more money, they were appearing on TV, they were writing books. But if you looked at internal performance metrics, you found that return on assets for 3 years following the receipt of their award dropped 15 to 26%. And then a recent example is Ron Johnson, who was appointed the CEO of JCPenney in 2011. 17 months later, he was out of a job and pretty much had wrecked that brand. But prior to that, he had had wild successes at Target. Here's my reference page, and thanks for watching.